Exhaust gas analysis. Let's look at the relationship between exhaust emissions and air-fuel ratio. Hydrocarbon emissions tend to be low in the stoichiometric or moderately lean range, rising with rich mixtures, also rising with mixtures that are excessively lean for the engine design. Carbon monoxide emissions are low in the stoichiometric range and rise significantly with a rich mixture. CO emissions stay low with lean mixtures. Oxides of nitrogen emissions are high in the stoichiometric or slightly leaner range. These emissions are reduced with cool, rich mixtures. NOx may also drop with excessively lean mixtures. Carbon dioxide readings are highest in the stoichiometric range and are off-peak when mixtures are rich or lean. Oxygen is low with mixtures that are stoichiometric or richer, and rises with lean mixtures. We'll use a 5-gas analyzer to measure the emissions. It should be noted that NOx emissions should be measured with the engine under load. Since this testing is done on the shop floor, I would not compare this gas to a regulatory specification. I'm placing the exhaust probe on a table during analyzer and engine warm-up. We can measure the gases before the catalytic converter, or pre-cat. A special tool can be used to punch the pipe, allowing us to use a needle probe on our gas analyzer. Measuring the emissions at the tailpipe is a lot easier, so it's far more common. We'll look at strategies to allow for this. The gas analyzer has to be zeroed. Again, the gas analyzer probe is on a table, sampling clean shop air. Here's our first look at the analyzer screen. Hydrocarbons at 0 parts per million, carbon monoxide at 0%, NOx at 0 parts per million, carbon dioxide at 0%, and oxygen at 20.91%, verifying normal analyzer oxygen sensor operation. We're testing a gasoline ported injected engine, pre-cat. The engine is running in the stoichiometric range. At 2500 RPM, hydrocarbons are 121 parts per million, carbon monoxide is 0.396%, NOx is 235 parts per million, carbon dioxide is 12.86%, and oxygen is 2.22%. Lambda is used on this gas analyzer, and it's 1.1. Hydrocarbons low at 121 parts per million. Carbon monoxide low at 0.396%. NOx normal at 235 parts per million. Carbon dioxide high at 12.86%. This combustion indicator signals near stoichiometric mixture. Oxygen at 2.22% indicates slightly lean of stoichio. Lambda at 1.1 indicates slightly lean of stoichio. The engine is now running rich of stoichiometric. At 2500 RPM, hydrocarbons 261 parts per million, carbon monoxide 7.789%, NOx 60 parts per million, carbon dioxide 7.9%, oxygen 1.71%, lambda indicating richness at 0.83. Hydrocarbons up at 261 parts per million. Carbon monoxide up at 7.789%. NOx down at 60 parts per million. Carbon dioxide off-peak or down to 7.9%. Oxygen down at 1.71%. Lambda at 0.83 represents richness. The engine is now running lean of stoichiometric. At 2500 RPM, hydrocarbons 154 parts per million, carbon monoxide 0.085%, NOx 68 parts per million, carbon dioxide 9.49%, oxygen 6.26%, lambda 1.43. Hydrocarbons slightly elevated at 154 parts per million. Carbon monoxide low at 0.085%. NOx low at 68 parts per million. Carbon dioxide low or off-peak at 9.49%. Oxygen high at 6.26%. Lambda at 1.43 represents leanness. Pre-CAD emissions are very useful, but tailpipe emissions are far easier to sample. The challenge here is that catalytic converter operation can mask smaller engine controls problems. The engine is running in the stoichiometric range. At 2500 RPM, hydrocarbons 0 parts per million, carbon monoxide 0%, NOx 5 parts per million, carbon dioxide 14.67%, oxygen 0.21%, lambda 1.01. Hydrocarbons, carbon monoxide, and oxides of nitrogen are all 0 to very low, having been cleaned up by the catalytic converter. Carbon dioxide and oxygen continue to be useful indicators of mixture. If carbon dioxide is off-peak, we look to oxygen as an indicator. If oxygen is low, we know we're rich of stoichiometric. If oxygen is high, we know we're lean of stoichiometric. In this case, carbon dioxide is at the highest reading yet at 14.67%, signaling stoichiometry, while oxygen is at the lowest reading yet of 0.21%. Remember, the catalytic converter uses some of the oxygen in the oxidation process. Lambda is at 1.01, almost perfect stoichiometry. The engine is now running rich of stoichiometric. At 2500 rpm, hydrocarbons 320 parts per million, carbon monoxide 8.72%, NOx 3 parts per million, carbon dioxide 9.3%, oxygen 0.27%, lambda 0.77. Hydrocarbons up at 320 parts per million. Carbon monoxide up at 8.72%. NOx remains low at 3 parts per million. Carbon dioxide well off peak at 9.3%. Oxygen remains low at 0.27%. Lambda at 0.77 represents a rich mixture. When mixtures are rich, oxidation converter efficiency is reduced. Hydrocarbon and carbon monoxide emissions remain high. The engine is now running lean of stoichiometric. Hydrocarbons 1 part per million. Carbon monoxide 0.002%. NOx 57 parts per million. Carbon dioxide 11.53%. Oxygen 4.73%. Lambda 1.28. Hydrocarbons low at 1 part per million. Carbon monoxide low at 0.002%. NOx up at 57 parts per million. Carbon dioxide off peak at 11.53%. Oxygen high at 4.73%. Lambda at 1.28 represents a lean mixture. When mixtures are lean, reduction converter efficiency is reduced. Oxides of nitrogen emissions remain high. To summarize tailpipe emission testing, hydrocarbon, carbon monoxide, and oxides of nitrogen emissions may remain low through minor mixture excursions or other faults. Carbon dioxide levels of less than 13% indicate mixture is rich or lean of stoichiometric. Catalytic converters produce carbon dioxide, raising levels above pre-cat values. If carbon dioxide is low and oxygen is low, generally below 0.5%, the mixture is rich. If carbon dioxide is low but oxygen is high, generally above 1.5%, the mixture is lean. Finally, elevated oxygen levels could be caused by misfire or exhaust leakage. Lambda could be thought of as the oxygen in the mixture. Numbers less than 1 indicate less oxygen present, richness. Numbers greater than 1 indicate more oxygen present, leanness. Let's test a gasoline direct injected engine at the tailpipe. The engine is running in the stoichiometric range. Hydrocarbons 130 parts per million. Carbon monoxide 0.379%. NOx 0 parts per million. Carbon dioxide 14.25%. Oxygen 0.58%. Lambda at 1.01 indicates near perfect stoichiometry. Hydrocarbons 130 parts per million. Carbon monoxide is low at 0.379%. NOx production might be high at the engine, but the catalytic converter is holding the tailpipe readings at 0 parts per million. Carbon dioxide readings verify stoichiometry at 14.25%. Oxygen at 0.58% supports that. Lambda is at 1.01, indicating near perfect stoichiometry. The engine is now running rich of stoichiometric. Hydrocarbons 1,030 parts per million. Carbon monoxide 10.5%. NOx 1 part per million. Carbon dioxide 6.85%. Oxygen 0.81%. Lambda at 0.70 indicates richness. Hydrocarbons up at 1,030 parts per million. Carbon monoxide up at 10.5%. When mixtures are rich, oxidation converter efficiency is reduced. Hydrocarbon and carbon monoxide emissions remain high. NOx emissions remain low at 1 part per million. Carbon dioxide is off-peak, low at 6.85%. Oxygen is 0.81%. Lambda at 0.70 indicates richness. The engine is now running lean of stoichiometric. Hydrocarbons, 56 parts per million. Carbon monoxide, 0.05%. NOx, 153 parts per million. Carbon dioxide, 12.3%. Oxygen, 4.15%. Lambda, at 1.23, indicates leanness. Hydrocarbons continue to be well managed by the catalytic converter and remain low at 56 parts per million. Carbon monoxide is also low at 0.05%. NOx levels are up at 153 parts per million. When mixtures are lean, reduction converter efficiency is reduced. Oxides of nitrogen emissions remain high. Carbon dioxide is off-peak at 12.3%. Remember, the catalytic converter increases the levels. Oxygen is high at 4.15%, indicating leanness. Lambda at 1.23 indicates leanness.